In this lecture, we will talk about Pandas series operations. So first is filtering values of a series. And many operations that are applicable to NumPy arrays are extended to the series. One of these is filtering values contained in the series through conditions. So for example, if you need to know which elements in the series are greater than 8, you can write the following. So first we create a series with 4 values and with index is from A, B, C, D. Then we can write S a bracket is larger than 8 inside the bracket. Then output is a series with the values only match this condition. The mathematical operations, other operations such as operators and mathematical functions that are applicable to NumPy arrays can be extended to series. For example, we can divide series by 2, then the result will also be a series with data type float 64, and the value, each value has been divided by 2, thus with same index as the original series. And other mathematical operations, like we can use log function, but we have to add NP here. So NumPy's function log, inside the parentheses is series, and output is a series with the same index as the original index, and the value has been calculated with the log function. And similarly, we can apply np.exp for exponential function to this series, and output is also a series with the value has been done with exponential function. Okay, evaluate values. You can check the values of the series, including existence of any duplicates and whether a certain value is present in the series. To know all the values contained in the series, excluding duplicates, you can use the unique function. And the return value is an array containing the unique values in the series, although these values are not necessarily in order. For example, third is a series with 6 values, numeric values, and index 6 labels with color. Then we can write third.unique. The output is an array with 4 values, because these 4 values is only unique values in this original array series. And we can also use the value counts function to return unique values and calculate occurrence of them within a series. The third.value counts will return a series, and here is the value is as the index in this resulting series, and the main value, data value of this resulting series is the count number of each value. And we can also use isIn function to see if the values are contained in the series, and the resultant Boolean values can be used to filter data in a series. So for example, third.isIn parentheses, and inside the parentheses is bracket is a list with 2 values 0 and 3. Then the output will be a series with the same dimension as the original series, and the index also be the same as the original series, but the main value has been a Boolean value with 4 true depending on the conditions they met for each value. And then we can use this series put in the bracket for the original series, then the result will be the values only match these conditions. So here we see only 2 values coming out in the result, only this one and this one. and NaN values. The specific value NaN, not a number, is used in Pandas data structures to indicate the presence of an empty field or something that's not definable numerically. Pandas allows you to explicitly define NaNs and add them to a data structure, such as a series. So we can define a series. Here, the third value, we write np.nan. These two alphabets is capitalized. So then we show this series, and the third value is nan, not a number. And is null and not null functions can be used to identify the index without a value, and the returned Boolean values can be used to fill the values of series. So we can write s2.isNull. Then the result will also be a Boolean type series. So only this one is true because it is not a nan value. So isNull will comes true for this value. And next we can use this condition to filter the values. So we write s2 bracket, and inside the bracket is s2.isNull. And the result is only this value will be printed out. Result is also a series. Similarly, we can use not null. Not null will get these three values true and this false. So we can filter values from s2 by this condition s2.notNull. The result will be a series with three values, and this index will be the same one in the original index. The series as dictionaries. An alternative way to think of a series is to think of it as an object dict dictionary. So in fact, you can create a series from a previously defined dictionary. For example, my dict is a dictionary with 4 keys and 4 values. You can see keys are like a color. So next we can create a series called mySeries using pd.series, and inside the parentheses we assign this dictionary here. So the result, mySeries will be a series, and the array of the index is filled with the keys, while the data are filled with the corresponding values inside the dictionary. So the values, dictionary's values, will be assigned as the main values of this series, and the keys in the dictionaries will be the index of this series. And you can also define the array index separately, in this case controlling correspondence between the keys of the dict and the labels arrays of index will run. So if there is a mismatch, Pandas will add the nan value. For example, we create an array called colors, but this time the color is not the same as the former dictionary's key. Then we create a series using this dictionary, but index we put in this new color. Then the result will be like this, because green value inside the colors index, but not in the myDict's keys. So this green's value will be not a number, but other four index elements are matched between this list and myDict's keys. So this 4 index has a value. And operations between series, the labels of series will come into play when we perform operations between two series. In the following example, we add two series having only some elements in common with the label. Then we get a new series in which only the items with the same label are added. All other labels present in one of the two series are still added to the result but have an NaN value. So for example, we create my series from another dictionary called mydict2. Then we add these two series together. Because these two series have not exactly the same index, so only the index appear in both series will be added with their values. Here is red and yellow, but the index appear in only one of the two series will have not a number value in the result. We will show all these statements in Anaconda Spider now. See the file called section 11 introducing pandas library.py, and the links to this file will be put in the description of this video. Then we move to lecture 3, pandas series operations. So filtering values. First we import library, pandas and numpy. Then we create a series with index ABCD, then run. So S is a series with index ABCD and these 4 values. Then we filtering value S, but the values are only larger than 8. Then only these 2 elements in the series comes out. The mathematical operations, we can divide series with 2. The result will be divided by 2 same index values. And we can also use a log function for S. Log function result for each value, index is same. Exponential function will run for each value. And we can evaluating values, create a series called third. This is a series with colors in the index and the value here. You can use a unique function. The unique value is only these 4 values in this series, and we can show the value counts. So 1, 2, 0, 3, their counts here is the value in the original series. Insert isIn. We can use isIn to see if the values match these 2 values. So only this one and the last one are true. The other 4 values are not match these 2. And we can filter out values. Only this one filter out. And not a number value. Create a series with one value is numpy.nan. So this series, the third value is not an, not a number. Then we can use this condition is null. You see the third value is true, boolean value is true, the other 3 are false because this one is not a number. Then we can filter out this one, because only this one is not a number. Also can use not null. Not null. All other 3 are true, not null. Only this one are null. We also filter out values. Only the opposite is only these 3 are filtered out. And series as dictionaries, we can create series using dictionaries. So this is series, and the index are the keys of this dictionary. The values are the values of this dictionary. Next, we can create a series by using dictionaries, but we can add another list as for the index. We will see how it's going. You can see the green is not a number because green in this index list, but not in this dictionary's keys. Operations between series can create a new series called mySeries2. Also use dictionary type. Then we add this series with the previous series, mySeries. We'll see the result. Only these two index has values, but these four all have value, not a number, because only red and yellow are common in these two series. But other four color, black, blue, orange, green, all these four are not common in two series, only appear in one of the two series. So their results will be not a number,